Hello friends, welcome to 360 Digit MG interview preparation session. I'm Sheila. Yesterday we were discussing about the possible interview questions on logistic regression. Today let's continue with the same topic since we couldn't complete all the questions yesterday on the same topic. So we will start up from where we stopped yesterday. Let me share my screen. All right, friends. I hope my voice is audible to you all. I hope my voice is audible to everyone. Yes, yesterday we discussed about some questions related to, let me quickly run through these questions just to know like what we missed out to continue, we will get to know here. What is logistic regression? Why it is used only, why it is used in binary class and or it is also used as, used for categorical when it is done with converted into numerical values. Okay, that is the first one. Make sure this first one, when I say categorical, we assume that it is either converted into numeric using 0 and 1 hot encoding or dummy variables, right? Just mention it here. Okay, here the model outcome is always 0 or 1. Even when we have the classes divided into yes or no, we are supposed to convert it into 0 and 1 using 1 hot encoding or dummy variables, right? In the same way, we also went ahead with understanding whether it is a classification or a regression model and whether it supports binary or multi. It supports binary class and it also supports multi-class. Okay, using one versus many or one versus all, right? So this uses generalized linear model. It means it's also called as binary logistic regression, binomial logistic regression, or logit model. Okay, what is meant by logit? We will come forward. Today we will understand that. And to highlight the qualities of this, it does not return the class of the observation, but it estimates the probabilities of the class membership. Say, it divides the training set based on the class available in the target variable, whether it is 0 or 1. It does not, unlike in linear regression where we get the output class in certain numeric values in a floating value. However, in logistic regression, we get only probabilities of the class. Okay? Probabilities could range anywhere between 0 and 1, which further will be classified based on the threshold. Okay, threshold value which we will be giving. With threshold value is something which we understand based on the business requirement. Like we can't give randomly any number like what we choose between 0 and 1, but it is very specific to the business requirement. So it is generally based on the business requirement, but on a standard practice it is 0.5. Okay, and is logistic regression a supervised ML algorithm? Yes, because the targeted variable is a categorical type or binary. So wherever I mention category, I assume that we are talking about converting it into 0 and 1 using dummy variables or one hot encoding. All right. Next, is logistic regression mainly used for regression? No, it is used, it is a classification algorithm. So we do not use it because the term regression, we get confused whether it is a linear regression with a continuous data or it is. So let us not get confused. It is basically a classification learning. So here There are different methods how we estimate, right? In linear regression, we use RMSE, MSE, and different types of metrics. But in here, we use maximum likelihood method. Okay. We also learned yesterday about packages, which we'll be using today for some more understanding, deeper understanding. In packages from Python and R, we have understood these are the possible pandas, NumPy, all of these we discussed yesterday. We used the metrics for ROC, AUC. We know that what is ROC curve and AUC curve. Yesterday we discussed what do we do with confusion metrics, that what are the parameters we consider while using metrics, confusion metrics, and the possible sklearn package which is used for train and test split, right? Then R we have various this one we have to use it XL actually. H miscellaneous, GG alley, GLM. GLM is basically generalized linear model, caret and information value. All right. So coming to understanding of AIC, why AIC is important for us? It is to understand whether our features added are significant to our model or not. Are they adding any value to our best fit or not? So when we identify the AIC after running the model, we come to know that lower the AIC, better the model, right? So that is what we concluded yesterday. As I see, many of you have been able to answer some of these questions. I'm happy about that. Well, next question. We discussed about variable selection. In logistic regression, we have to identify which variable is adding, being significant in predicting the model. One of the ways of doing it is lasso. This one actually is a regularization parameter which and penalizes the coefficients. Some of them may become 0 or close to 0. That way, the impact of the less significant variables will be removed, meaning the ones which are not adding any significant to the model, they can be removed. So that is the part of variable selection. Okay. In probabilities in logistic regression, they lie between 0 and 1 as we discussed, and using a threshold value 0.05 is a standard one. So we have learned a little bit about confusion metrics yesterday. Let's do it in detail today. Okay. So what we discussed about it, I would expect you to answer whatever you have understood with confusion metrics. Right? Anyone? Yes. Yes. What do we understand by confusion metrics? Ravi, you're asking for a PDF. I'm not quite sure if we are supposed to do that because this is a live session. You can even make a note. I'm going a very low pace. You can probably watch this again to get an idea what we discussed. And this session is primarily for helping you guys to know and get familiar with the common terms and the questions that you will come across in the interviews. So if you look at the content of the page, you should be able to get the content even in the material anywhere online or things. But the focus is on the kind of questions that you will be facing. So I would appreciate if you pay attention to the questions that we'll be raising here. Then the content, because the answers are available everywhere. So this is primarily for you to understand the questions, possible interview questions. You can take advantage of that in this session. Yes, Ravi. All right. Ma'am, voice is low. Okay. Is it better now? Is it audible? If there is any problem in the sound, please let me know. Yes. If there's any sound, voice is not clear, please let me know before I go ahead. Right? Is it clear now? I believe it is clear. Okay. All right. Let's go back to confusion matrix, whatever we have understood yesterday. Uh, Going by that, the columns are always predicted values and the rows are always actual, but you may see the changes as it depends on how you are able to read the parameters inside the table. As going by the name, it is a confusion matrix. It can cause confusion. So if you stick to one method of columns being in the predicted values being in the columns and actual values being in the rows, it will help you to figure it out easily. So that's how I remember it. Here, these are the predicted values. When the class, when this is a true positive and true negative, false positive, false negative. Let's understand what exactly we mean by that. Observation, when you say P, this observation is positive and then observation is negative, like 0 and 1, whatever you want to design it. And true positive, its observation is positive and it is predicted as positive. So that is very important for our model, that when there's a positive, when there is a value 1 and our model has detected it as value 1. So it's a good point. True negative, where the true negative means observation is negative and it is predicted as negative. So which is the right thing for our model to do. Okay, these are very important, true positive and true negative. However, when we are calculating the accuracies and furthermore, when we are analyzing our model, we also look at the false positive. How many false positives are coming up and how many false negatives. In observation, our observation is negative, but it is predicted as positive. So that means it's a false prediction. That is called FP. Right? If our observation is 0 and our model has predicted it is 1, then that's an error. Right? Similarly, if our observation is positive, but the model has predicted it as negative, right? It was 1, but the model has turned it into 0 in its prediction, which is another matter of concern. So how do we calculate the accuracy in this case? We calculate, yes. Can anyone answer? Which question, Sailaj Padma Pavani? Do you repeat the question once, please? What do you mean? Which question? Yes. I'm sure many of you have gone through this topic several times in the past, but it's always good to revisit, because it is a little confusing topic. We want to repeat it once again, so I did not mind going back and repeating a little bit about what we learned yesterday. Because it's a very common question, what is confusion matrix and what are the parameters considered, and how do we calculate accuracy, specificity, and sensitivity. We'll go about it now. That's right, Neelam. You're right. Total positive plus total negative by total. Right. That's good. Good. That's what we have here. And true positive rate is also called as recall. And yeah. And next, sensitivity, the number of correct predictions divided by total number of positive predictions. Right. Yes. Yeah, I'm able to see your answers. Yeah, correct. Yes, any more answers? Yes, sensitivity or hit rate. You're right. You're right. So sensitivity, we also call it as recall, right? Which is called as, which we can write it as a true positive by false positive. Okay, this is what we have written it here. And what is true negative, which is also called as specificity, right? So what is true negative? Total true negative by true negative plus false positive. All right. This is the one. What is precision? Yes. What is precision? What is precision? Yes. What is precision? So we know already, we have understood what exactly these are. I'll just read it again. True positive rate, right? True positive rate, it is the ratio of positives correctly predicted from all the true labels. In simple words, it's the frequency of correctly predicted true labels. Okay, and similarly for true negative rate, we have the frequency of correctly predicted false labels, right? And then we have a false positive rate. What is false positive rate? False positive rate. What is false positive rate? False positive by n plus false positive. Okay. Please make a note of this. False negative rate. N by Tp plus Fn. Okay. Am I clear? Am I audible to everyone? Yes. Yes. Is it audible? Yes. Precision is what proportion of positives were correctly identified. You're right. Right. So in this, we will also come across something called as type 1 error and type 2 error. What is type 1 error and type 2 error? Yes. What is type 1 error? False positive. False positive rate or 1 minus specificity. Okay. Similarly, false negative rate or 1 or 1 minus sensitivity. Okay. This is, in short, I'm trying to give you the. So these are very common questions you have to remember and go with preparation on these kind of basic questions. Yes, what are the, where is 1 minus 2 negative, false positive error? Yes, you're right. Yeah, type 1 is also called as alpha. Yes, type 2 is beta. Right. What is F measure here? What do you understand by F measure? What is F measure? Yes. What is F measure? What is F measure? So in short, we can call it as it's an average weighted average of the both precision and recall, right? 2 times of precision and recall by precision plus recall. We can write it like this. So in order to define it, it is like, it is a harmonic mean of precision and recall. In some cases, there will be a trade-off between the precision and recall. In such cases, the F measure will drop. Okay, it will be high when both precision and recall are high, depending on the business case at a hand. Goal of analytics, like whichever model that we want to build, an appropriate metric will be assumed. For example, uh, how much accuracy you're ready to compromise on, how much incorrectness in the model you're ready to compromise on. So those are the things that business will take a call on. But for us to understand, F measure is basically it's a 2 times precision into recall divide by precision plus recall. Okay, this is simple formula. You might want to remember it easily. Okay. Right. So what are the next questions? How do we have already understood what is accuracy, what is sensitivity and specificity. Then what is, how do we do the cutoff point? Okay, there's one thumb rule on which we can identify what is the cutoff value in order to identify the proportions, right? One way of doing it is proportions of positives in a data set can be considered in order to do the threshold value identification. For example, sometimes it also depends on business objectives as to, whenever we have the ROC curve and define a value for it, right? Where I mentioned it is 0.0. So it is very critical to identify what is the exact threshold value that we should give in our model. Many a times it will be based on the business requirement, but a thumb rule can be, it can be chosen that is equivalent to proportion of positives in the data set. If you couldn't identify anything, at least we can do a proportion of positives in a data set. Okay, one of the cutoff value is selection based on proportion of positive data set. Okay. Okay, there could be another question like how does logistic regression handle categorical variables? We have already understood this part, right? We will be using unique numeric value using dummy variables, right? That we already have understood. And what are the other things that we can work on is, let's understand what is logit function. Okay, what is logit function? Or before that, let me ask you, what is odds ratio? What is odds ratio? Anyone? What is odds ratio? Yes. What is odds ratio? This is a very common question. The whole idea of logistic regression depends on this formula, odds ratio, right? Yeah, e raised to y by 1 plus e, that is a logit function, yes. But I'm trying to understand what do you mean by odds ratio. So, for example, you have a coin, head and tail. It has two faces, head and tail. So if you flip a coin like 3 times, what is the probability of getting heads 2 times, right? How do we understand that? What is association between exposure and outcome? What do you mean by exposure? What do we understand by exposure here? Yes, yes, Sailaja, Padma, yes, you're right. The ratio of success to ratio of failure. It's not the ratio of success to ratio, it is the ratio of success, right, with number of failures, like, p by 1 minus p, right? Non-linear to linear pattern. So just to give you an idea, let me write it down. It is odds ratio. If there is a question on logistic regression, you can expect this particular question for sure, 100%. Okay, odds are defined as a ratio of probability of success by probability of failure. So, in case of fair coin, right? Assuming that both sides it is proper head and tail, and probability of getting success and the probability of getting failure. I mean, success or failure. It will be always 0.5, 0.5 because the total value is 1, right? The probability is always 1. So the total, so how do we define it as ratio of probability of success and the probability of failure? That can be quantified as log of p by 1 minus p. This is called logarithm of odd or log odd. Okay. So ratio of probability success with the probabilities of failure. So there is something that we do with our, even when you're working on R or Python. In R specifically, we try to take the exponential, right? We take a log of it. How do we do that? Log of that is p by 1 minus p, where p is the probability of success and 1 minus p is the probability of failure. Okay, that will give us q. Q is the probability of failure and p is the probability of success. That is the idea. This is also called as logarithm of odd. So for this, we will apply log to quantify it. P. Right. This is called log odd. So here the odds reflect the likelihood that the event will occur. Okay, it can be seen as a ratio of success to non-success. Here I have mentioned ratio of success or failure. Successes can have multiple successes in flipping the coin, right? How many times you want to flip the coin. So if you're desiring for head and you're getting head as many times, so that will be considered as success. And the other ones is always non-success or failure. Okay. So I think one main thing that we missed yesterday is assumptions, that we have not covered the assumptions of logistic regression. Unlike in linear we follow line assumptions, right? In logistic regression, which we have sigmoid curve, right? What are the possible assumptions that we can list out? Can anyone tell? Anyone? Yes. What are the assumptions in logistic regression? In linear regression, we have line assumptions where we assume that the linear relationship between the predictors and the targeted variable, and we have equal variance between the errors, and we have uniformly distributed input variables and errors, right? Error should be independent and exclusive, and we have to check for autocorrelation or any correlation between the input variables. So these are the assumptions that we have in linear regression. But what assumptions do we have in logistic regression? Yes. Yes. Data is normally distributed. Okay. What if my data is categorical variable? How do you consider that as normally distributed? Error term. What is error term in this? Error should be distributed normally. Okay. How do we define error in logistic regression at first? See, you're listing out all of this from the linear regression, but there are slightly different things that we need to consider in logistic regression. It's not same as this one. Zero to one, okay. Right. Okay, so let me list it out. First one, what we can see is, since the data is in binary, so binary outcome. So because it's a binary outcome, at any given time, there will be only one outcome, right? You can't have dual outcomes. So only one outcome per event. If you flip a coin, can you get head and tail together? No, you can only have one. So between binary outcome, it will be either 0 or 1, pass or fail, disease or no disease. So that is one assumption, right? Second one, anyone else? Anybody? Residuals, large sample data, multicollinearity, binary logistic regression, dependent variable be binary, log odds. Okay, so there is a mixture of answers. Well, I think I will just write it down for your clarity. Outcomes are statistically independent. What does that mean? What does that mean? Outcomes are statistically independent means there is no collinearity between them. Okay, there is no collinearity or correlation between the input variables. To assume that any feature or any variable that is added to the model, that should have influence on the targeted variable. Okay, selected predictors should influence the predicted class. So if there is no influence of a specific variable, I would rather mention it as variables just to avoid confusion. So there is this synonym, right? Variables or predictors, attributes, features, all of these are same. Okay, they're all same. Input variables, all of them are treated as like x parameters, x1, x2, x3, right? That's the one. Right. These are assumptions, okay? So like we discussed, there can be any one between head and tail. It has to be any one for each event. Actually, this is very similar to the first binary outcome, right? Any one event per, any one outcome per event. Head or tail, it has any one for each event. That means you call it as mutually exclusive. Right? Next. This we assume that logistic regression data set is relatively large. large enough, because we cannot work on this with small data set. Okay, that is one of the assumptions that we need to remember. And okay, one more question we will come across is what is so we all must have prepared a model, basically logistic regression model, using one variable or two variables, or depending on the data set that you are given. In that, once we have prepared a model, we will notice in our model there's null divines and residual divines in our parameters, in our results when we run the model, right? What is null divines and residual divines? Yes. What is null divines and residual divines? Yes. What is null divines and residual divines? Anybody? So, for us to understand what is null divines, before that we know what is degrees of freedom. What is degrees of freedom? What is degrees of freedom? Error values in data, yes, that is null divines and residual. Yes, we can begin from here. I can tell you the exact meaning. Anyone else? Yes. Yes. N minus 1. What do you mean by n minus 1? Degrees of freedom n minus 1. So why do we have it as null device separately? Right. So you're pretty much close to the answer. So we have null divines to identify how well the response is predicted by the model, right? So typically this is a beta naught, sorry, beta naught, that is an intercept, right? That's why we always take it as n minus 1. Okay. Why we take it as n minus 1? Simply because how well the response is predicted by the model with nothing but an intercept that will give us. And similarly with the residual divines shows how well the response is predicted by the model when the predictors are included. Okay, we have to always notice null divines and residual divines should be always, the difference between null divines and residual divines should be always high. Can anyone tell me why we need to have a bigger difference between null divines and residual divines? Right? Yes. These null divines and residual divines. Depending on degrees of freedom, we say null. Okay. So, uh, so there is a very little difference when you actually look at the meaning of the two sentences. Null divines and residual divines are characteristics to identify the degrees of freedom whenever you introduce or add the variables to your model. So when null divines is when you have not added any variable to your model, and it is only how well your model is able to be predicted using nothing but an intercept. Okay, B naught. Whereas in residual, what we understand is when we have number of predictors, we could have x1, x2, x3, x4, and so on. So each of these will come with the weights, right, with some coefficients. And added to that, how well our model is predicted using these additional predictors such as x1, x2, x3. Right, and whenever we see there is no much difference between null and residual divines, that means there is no difference much. That means our predicted variables, our predictors are not adding much value or not significant enough in the model, right? Understand? To get grand mean, null is predicted value of response. It should be high when compared to residual. I would not say high or low, but there should be a difference. Okay, there has to be a good amount of difference between the null divines and residual divines. That is the whole idea. Okay, let me write it down. Null is nothing but beta naught. I will just mention as B naught. The degrees of freedom n minus 1, as you all said. Okay. So this how we will calculate. What is n here? N is number of observations. Okay. Whereas how well the response nothing but an intercept. Okay. So residual lines is B1, B2, B3, Bn, depending on the number of variables you have added. So that will be total number again. We have n minus number of Bn, meaning how many variables are added to it. Say, example, if you have 5 predictors added to your model, then n minus 5. Okay, this is how it is prepared, degrees of freedom. So note that this and the predictors are added. Always remember the node. There should be a good difference in the accuracy. Higher the difference, larger the predictor significance. Understood? Always, if there is no much difference between null divines and residual divines, that means our predictors are not significant, not influencing or the variable. Okay. I hope I'm clear. Is my voice audible? I hope the concepts are clear here. Okay. There are a few parameters which I wanted to give you all an idea about. There are, yes, Sailaja, for best model difference should be high, correct. Right. So there are few hyperparameters that we should consider for fine-tuning the model, right? Any kind of model, we have to understand that the obtained accuracy can be improved if we fine-tune the parameters. What are those parameters that we can work on to fine-tune them? Anyone? What are the parameters that we can fine-tune in order to improve the accuracy of the model? Yes. Parameters. Hyperparameters are typically used to improve the errors, to reduce the errors and improve the accuracy in the model. One of them, a few of them, we are not discussing all of them, but we will see a subset of the hyperparameters which are commonly used in building the model. One of them is solver, right? Solver. Another one is penalty. Right? have a C, or we have intercept, maximum iteration. Max iteration. Vector. We have to mention the random state. Random underscore state. Right? What is random underscore state? I mean, this hypertuning, we have to mention this. I'm sure many of you have used it in your model, but what is the meaning of that? What is the meaning? Basically, this is an instance of NumPy, right? Which is used. We have it in Panda. It is a pseudo-random number generator, right? Number generator. So, random number generator. Random state. Solver, we can have liblinear, we can have could have etc. I think we need one more session for L1 L2 or last maximum iterations integer value. We have many more hyperparameters to consider in order to fine-tune our model. Maybe in the next class or some other session, we'll be able to discuss more in detail about the hyperparameters. All right. I hope the session was informative and helpful for everyone. Time to conclude the session. We can meet up tomorrow at the same time. Thanks for watching, guys. Have a good day.